All right, so it looks like we're recording. Last time I noticed a big light reflection on the board, so I'm just going to go with ambient light. Just pulled the blinds up, and let's see if the video comes out well enough. So this is a Joybells practice time. I'm going to lecture a little bit on how to solve how to solve all triangles and what it means to solve all triangles. But let's start with a quick review of language and communication, symbolic communication, and what you're supposed to be working for inputs to outputs. So we talked last time, I got a little arrow here, that this is a command. This is a function, f of x equals input, output. You get a y value, right? You put a number into a calculation, you get an output. And so what are we putting into the sine command? An angle. You know, we're looking at opposite to hypotenuse of a right triangle, put in an angle, and you get a ratio, and all those ratio values are stored. Okay? And when we use this notation, that's the inverse of a function. This is the inverse of that, which means that we're starting with the ratio and going back to the angle. So pay attention to that. Okay, let's get a little practice right now with that, and then we'll talk about how you solve right triangles. Okay, look at repetition is my friend. I put a couple of things on the board, save some time. All right, so we're going to get to this solving triangles, but first, how about a little work, a little wake me up, and a little calculation here. So, you know, you do parentheses first, right? And then please pardon my dear Aunt Sally. You can forget all about her because she doesn't exist with tangent and arc cosine. You know, I think we've gotten past multiplication and addition and subtraction. Okay, we're going up the ladder. All right, so how do you do order of operations? Parentheses first, and then the hardest problems, the hardest operation to the easiest. Okay, you kind of follow the historical development of the subject. All right, so let's see. Here's a parentheses right here. Can you give me an approximation of that calculation? Oh, we're right back to the other side. Cosine inverse. We're looking at ratio. All right, so I'm hoping that you give me an angle. All right, I took the quiz myself before I put it into the arc cosine calculator that Google has so nicely given to us for free. Nothing else is free on there. You're looking at ads all the time. But they gave us the arc cosine calculator for free. And so I looked at my circle and I said, okay, remember, you're pausing this video, right? Before you kind of watch these explanations. Hey, arc cosine's the top half. That's 0. That's minus 0.5. So I'm saying right about there. So we're looking at something that goes to right about there. Okay, well, I know 0.5 is 120 degrees. I'm going to go in degrees right now. We'll talk about radians in a minute. And I know 0 is 90 degrees straight up. And I'm somewhere, I didn't draw that well. I'm somewhere here, past 90. It's not a great drawing. I know that right up there is kind of 1-to-1, the arc and the width, about 1-to-1, but then it falls off. So I said to myself, 120 degrees, 90 degrees. I'm a little more than halfway, you know, and it's going to take me a little longer than just halfway because it's dropping off. So I guessed 110 degrees just quickly. That was my quick guess. And it turned out it was 107.45 degrees. That's what it was, 107.45. And I never did do the what is it in radians, but let's do it right now. So I got to get a good drawing. This isn't a good drawing. But so I'm thinking this probably comes down a little quicker. That's 1 radian, 1, 2. Okay, so it's less than 2. And it turns out the arc cosine free calculator on Google said 1.86 radius length. That would have been, you know, let's get this out of the way. Let's get this. So it is looking a little lower. Let's just start again. That's a better one. So 0.3, -1's over here. So right about there. So we're looking at there. Now I got the angle from the origin, right? So that's 100 and what it was, 107 degrees. 107 degrees takes me to that ratio, and it's supposed to be 1.86 radius lengths takes me there. All right, so I'm not going to talk too much longer about this, but what does this become? This becomes the angle. This becomes the angle of 107.45 degrees. So now I'm doing the tangent of an angle. Tangent of an angle. And how do I find that answer? I put it in a calculator and get it. But we don't need a calculator for these problems. We've been doing these problems. I got to find my eraser. Here it is. So let's cut to the chase. And remember, hopefully you paused this a while ago. And so the tangent, arc cosine of minus 3/10. So let's say this is minus 3. That's about 10 right there. And we do Pythagoras. That's the 107 degree point. I forget what it was, 107 degree dot point something angle. And now we're looking at, this is the reference angle. That's the reference angle. And so, 100 minus 9, 91. So this is the square root of 91. What's the tangent? Opposite over adjacent. So we're looking at putting the negative in the numerator. And that was your answer. Okay, but I wanted to layer it a little bit, you know, just continue to deepen the conversation. All right, now we're going to solve triangles. Solving triangles means finding all the angles and all the side lengths. We've touched on right triangle trig for a while. So there's 6 possible ways of solving triangles using right triangle trig, which is using either cosine language or cosine inverse language. There's law of sines, which is either using sine language or inverse sine language. And there's law of cosines, which is either using cosine language or inverse cosine language. Okay? So I'm going to do them in order here. I'm just going to go through them in order. And so the next time when I make a video, we'll just throw them at you randomly and make your brain work a little harder. Okay? You have been trying to solve triangles, right triangles, for weeks. So I'll just give you a right triangle. Okay? Here's a 90-degree triangle, and I'm going to say I'm going to use x's and y's instead of a and b from now on. And I'm going to use x's and y's. So the x distance in standard position is 5. The hypotenuse we'll call it c. The hypotenuse is, let's go 11. Okay, and let's see if we can find the y value. What's the y value? All right, how would we do that? Well, I know that's more than one step. So let's find angle x, big X. And this is little x. They look too much alike. We're going back to standard. Okay, A, and we're going to find capital A. Okay, let's go back to standard stuff. We'll get into some vector work later, and based on this process. Okay, we'll make that change in a week or so. All right, so pause the video, you try it. I don't have to pause it, I just do it. All right, I've been given a picture. I am trying to find angle A. I'll draw that, which means that this is opposite to it. They're opposites, all right? And that's the hypotenuse. So what have I got? Well, we'll shortcut this problem in a little bit. I'm going to say eventually that's a y value, right? But right now we're looking for, I forgot what we're looking for. Oh, angle A. Trying to find angle A. Well, I've got a ratio. Do you see what ratio you have? I do. I see the inverse sine ratio of 5 to 11. And Google has been very kind to us there too. Nice free arc sine calculator. So you go to the Google, type in arc sine. It'll give you a choice of radians or degrees. I say, look at the degrees first. What do you think it is? Well, I know what 5 over 10 is. 5 over 10 is a half, so I know that's 30 degrees. So this is 10 would be shorter, right? So therefore, this is a little less than 30 degrees, but you go check it out on a calculator. Right? All right. So here's our choices. We just did one. That's the arc sine. All right, let's do another one. How about if I said, I want to find the, I'll give you angle B this time. I will give you angle B. Let's say that angle B is 29 degrees. Okay, and let's say that little a is 8. Little a is 8. Can we find little c? It's a side length, right? Can we find little c? The hypotenuse. So you try it. All right, I'm just going to do it. I got a nice picture here, 29 degrees. This is angle B. There's about a 29. And A is 8, so that's there. And C, I'm trying to find C. I was given this, so this is 29 degrees. And this is C. I'm trying to find that length. Geez, that looks like a ratio, 8 to 8. Can you see that? Yeah, no. Got to look it down here. All right. Oh, that other one came out. So 8 to some unknown. We'll call it little c. Now that's a ratio. Sure looks like I've been given the angle, and that's the cosine of 29 degrees. Yep, and that's over 1. All right, and we talked about reciprocals in the last worksheet. If you uploaded it, if you looked at it, just flip it, right? And if you flip it, I mean, I don't want to go to secant language. So anyway, all right, let's just take care of this quickly here. All right, so multiplication by c over here, and then division by the cosine of 29 degrees. And you should have a feel for the cosine of 29 degrees. It's pretty close to the cosine of 30. You should be able to do that in your head right now. Root 3 over 2. So this number is about 8.87, right? And it's a little further out, so we'll call it 0.88. Is that going to fit into that? Yeah. I don't know how many times, right? It's a little smaller than 1, so it goes in more than 8 times. Maybe this is a length of 9. Does that seem reasonable? Yeah, I mean, you have to go to the calculator, right? You'll actually have to type 8 divided by the cosine of 29 degrees. But Google's been very nice, kind to us. They have a calculator. In fact, all you have to do is type that in the original Google bar, space bar. I don't know what you call it. All right. So that takes care of how you solve 90-degree triangles. And there's 6 methods. And we've just cut down 2. I'm a math teacher. That means there's 4 left. 2 of them we've practiced. All right. 2 of them we've practiced. Law of sines. Let's see if the law of sines really works. Let's see if the sine of angle A divided by A is equal to the sine of angle B divided by angle B for a triangle we know. How about the sine of 30 degrees? Compares to a half, the way that the sine of 60 degrees, sine of 60, 30, 60, 90, yeah. I didn't think this through. Compares to root 3 over 2. Seems to be true. Not sure why I just did that. I'll just keep going. And then with repetition, I'll figure out why. I don't think I gave the best example there, but it is something like 90 to 95 today. I had to shut the fan off, and this house is heating up. So we're just going to keep moving along. It's not as hot as India. Maybe it is. We've got a lot of humidity right now. All right, so law of sines. So let's say that I give you A equals 4, B equals 5, and C, we don't care about C right now. Let's go, angle A is equal to, let's go back to 29 degrees, because we know 30 degrees is a half. That gives a feeling for the calculation. So what's B? All right, law of sine says the sine of angle B compared to its opposite side is equal to the sine of the angle given compared to its opposite side. All right, so running out of room here. All right, I can get one more line of work in. So I'm going to multiply by 5. That gives me the sine of angle B is equal to 5 times the sine of 29 degrees over 4. Remember, the sine of 29 degrees is a little less than a half, right? This is similar to maybe 0.49, 0.48, right? Half of 5. I now know I had trouble in the last homework. I was dividing 0.5 by 2, and somehow I forgot the decimal. Anyway, half of 5, 2.5 divided by 4. Well, 2.5 divided by 2 is 1.25. Divided by 2 again is 0.675. So this thing is around 0.675, all right? So what angle gets me 0.675? 0.675, maybe that kind of angle, all right? But Google has kindly given us a calculator because I am going to isolate B right here. How am I going to isolate B? Back to the top of the screen. What undoes the sine of B? Inverse sine. So I am going to go to the 5 times the sine of 29 degrees divided by 4, and that's a ratio. And what's a ratio going to be? It's going to tell me that angle. Google's been very kind to us. So if you want to type that into Google, it'll tell you. It'll tell you what your angle is. Okay, so we're still using this language for all of our solving of triangles. That's the third method. All right, when you have an opposite side, it's not right triangle. This was not a right, nothing here did I say right triangle. If I don't give you a 90-degree angle, and if I don't say it's a right triangle, you aren't going to use right triangle trig. You're going to use law of sines or law of cosines. Now, we'll do the other type. All right, the other type. Maybe I'll even give you a quiz on all 6. I lied to you before. I don't like it. Sorry. I might just go back and say, okay, here's 6 situations. Can you identify which one you use for each? But we're going to do it the whole rest of the way, right? Yeah, especially this fall when you take the 411 class at NMH. This is all going to get repeated, plus the Algebra 1 and Algebra 2. So you can't get away from it even if you want to. Okay. All right, and I know you don't want to. So where am I? Okay, we solved. So we're going to solve for little b this time. I'm going to give you a big B. Okay, probably should give you big B is what, 90, 70, 61 degrees. 61 degrees is big B. All right, so how do you solve that one? Much easier. All you got to do is put your unknown unknown in this case is little b, compares to the sine of 61 degrees, the same way that little a, which is 4, compares to the sine of 29 degrees. We should be getting exact answers back and forth here, but talk about that later. Oh, it's real easy to get little b alone. It's just 4 times the sine of 61 degrees. It's that simple. You should have a little feel for the decimal of the sine of 61. It's pretty close to the sine of 60, isn't it? You should be able to visualize the sine of 60 in the first quadrant, root 3 over 2, and you should immediately know that's about 0.87. Okay, so, and this is about 0.5. So what do we have over here? We have a ratio, right? And where did we get it from? This language, right? We had the angles, right? We have the angles. This language is going to give us a ratio. What ratio is it going to give us? Something close to 0.87 times, I'll put a parentheses, 4 times 0.87 divided by 0.5. It's going to be close to that. Okay? Now, 0.5 into 4 is a half into 4 is 8. 8 times 0.87, right? A little while ago, we did 8 divided by 0.88. I think we're doing probably the same problem here. I don't know. I got lost in the minutiae of that, but that's 4 out of 6. 4 out of 6 methods here. So the last one is the toughest one, which is the law of cosines. And the law of cosines is a couple of page proof in a text. Google it, read about it. It's not necessary that you digest everything in there. Just recognize that some bright mathematician looked at the relationships of the Pythagorean relationships and played with them and came up with this. Speaking of Pythagoras, so let's look at c squared. That's little c equals a squared plus b squared minus 2ab cosine big C. All right, this is what we're going to be working with. Looks a little bit like the Pythagorean theorem, doesn't it? Well, in fact, that's where the Pythagorean theorem came from. Let's look at minus 2ab cosine of 90 degrees. What is the cosine of 90 degrees? If you said 0, you'd be right. And 0 would get rid of this. And what are you looking at? Pythagorean theorem. Okay? So this is how I work with law of cosines. And you use law of cosines when you have side angle side. Okay? We do not have let's call this angle A. We do not have little a. We do not have an angle and its opposite side. And it's not 90 degrees. That's when we come to this calculation, which I'm going to simplify for you, and we're going to work with the simplified version the rest of the way. If you have to multiply something, you might just as well multiply. If you have to memorize something, you might just as well memorize the last line of work. What's the point of going through the whole thing? Okay, I mean, I will go through solving so that you see where this comes from. That's a bit of a lecture I'll do here in about 2 minutes. Okay, but let's say that we have a triangle. This is not a right triangle, although it looks like one. Let's see, how can I do this? That better? Yeah, that's better. Well, it still looks like a right triangle. I'm terrible at this. Here we go. Bam! That's better. All right, there we go. So we got a big angle here, right? Why don't we call that 100 degrees? And let's call this 8, and let's call this 5. And we're trying to find that length. That's when we use this. Okay, so what is this? This is little c squared. We don't know it. What's the inverse of squaring? Square rooting. All right, so this is what I want you to memorize for this situation. Side angle side, non-right triangle. Boom. Side angle side, non-right triangle. Boom. Okay? All right, so all we do is plug in the values. So what do we have? We have c is equal to the square root of a, doesn't matter whether you call this a or that, doesn't matter, the other two sides, 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 100 degrees. Now, what is the cosine of 100 degrees? Positive or negative? Hope you said negative, right? 100 degrees. There's that kind of triangle, right? And we're looking at this width. And what's a negative times a negative? A positive. So we are a little bit bigger than the hypotenuse. This would have been the hypotenuse right there if it was 90 degrees. We're a little bit bigger. I'm not sure if I just said something that's true there. But anyway, sounded good. All right, so I'm going to leave that on the board. I am now going to solve this for little c. All right, and then we're going to get, oh, because what do we have here? We have the cosine of 100. We're working with this. We're always working with one of these 6 symbols. Okay, right now I'm turning around. And I'm going to solve for the angle. So what if we have a side, side, side? Let's say we have a 5, 7, 9. I don't know if that's drawn anywhere near right. A 5, 7, 9 triangle, and I want to find that angle. I'm going to show you how we do that and what we memorize. And it's going to take you 4 straight days to memorize it. Then if you don't look at it 4 days in a row, you won't. You won't own it. If you do look at it 4 days in a row for 2 minutes a day, you'll own it. So that's on you. That's on me. I just put a mark on the computer. Here we go. Oh yeah, so we're going to call this angle C, all right? And this is little c. All right, so c squared equals a squared plus b squared minus 2ab cosine big C. And we're going to solve for this in a minute, which means we got to isolate all of this. Step 1, change the signs of everything. It makes life a lot easier. So let's make this minus c squared equals minus a squared minus b squared plus 2ab cosine big C. Okay, that makes life a lot easier for us because now subtraction of a squared minus b squared, I'm going to just do this here. I'll do it on this line of work. I'm going to add this to the other side, add this to the other side, and then I'm going to divide by the coefficient here of that term. I think I can say coefficient of that term. So what do we get? Positive a squared, positive b squared, minus c squared, divided by 2ab equals cosine of big C. And what is big C? An angle. We're trying to find an angle. What symbolic notation finds an angle? We use angles over here. Oh yes, ratios. ratios with this language finds angles. Oh, yes. And what is this complicated mess over here? It's a ratio. So we take that ratio and we go to Google, because they've been very kind to give us a free arc cosine calculator that takes ratios. There we go. We just undid that. Takes a ratio and tells us the angle. Okay. What would that angle be? I don't know. Probably close to 100 degrees. I don't know. That's where my brain's been at here recently. Okay, so that's the 6 ways of solving a triangle. So I'll just do all 6 situations. I'll mix them up. And you have to memorize this, right? But you pause the video and look at it. So if I give you side, 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 and what if I give you A equals 3, B equals 4, and C equals 5? Can we agree that's a right triangle? So if I wanted to find angle C, we know that's 90 degrees. We know that's 90 degrees. In a 3, 4, 5 triangle, C is 90 degrees. So this should work for that. So A is 3, so that becomes 9. B is 4, that becomes 16. C is 5, that becomes 25. And we can see 3 times 4, not that we need to do this because this is 0, right? But 24. So what do we have? We have 0 over 24. And what is 0 over 24? What is 0 divided by 24? That's 0. And what is the arc cosine of 0? Arc cosine is the top half of the circle. It goes from 1 to -1. There's 0. Oh, yes, straight up 90 degrees. All right, so here's your 6 situations. Let's see how many you can get. I think we'll start with, let's say we start with A equals 3, B equals 5, big A equals, how about 47 degrees? Can you find big B? Woo, it's getting hot here. Let's see, you can't see that. Now you can, okay? Little a is 3, little b is 5, a is 47, b is what? Now we're not solving the entire triangle. Solving the entire triangle is all 3 sides, all 3 angles. We're just getting practice solving one missing piece. But if you can solve one missing piece, you should be able to solve the rest, okay? Whew. Okay, gotta wipe the forehead. It's getting mighty hot in here. So I'm gonna do these 6 pretty quickly or I'm gonna be a drenched old math teacher here. Oh, whoa, I see a side length and an angle opposite it, and nothing says 90 degrees. So I'm not gonna do 90-degree triangle stuff, no. I think I'm gonna do law of sines. And this is my unknown. Oh, I think I'm gonna go the sine of B is compared to its opposite length the same way that the sine of 47 degrees compares to its opposite side. Yeah. Oh, wow. Huh. Geez, I think I'm going to move 5 over to the other side, and because it's so hot, I'm just going to take some liberties. Huh. Now I got to get B alone. Oh, this is a ratio. Oh, I know the language that goes with ratios. It's inverse. You use inverse sign communication, symbolic communication, to get a ratio. And I should be able to come up with a fairly decent approximation of this ratio because I know what the sine of 47 degrees is close to. It's close to the sine of 45 degrees, 0.71. So we'd go to the calculator and we would do 5 times, roughly 0.71. Obviously, sine of 47 is higher up, so it's probably 0.723. I don't know. Calculator is going to give you that number divided by 3. And that baby is going to give us, I hope a triangle that can be drawn. I mean, there's more things than, we got one other situation where you can get 2 triangles. We're not going to go there. We're just going to do these 6. All right, get a feeling for it, really get it under our belt. And then if we get some ambiguity down the road, we'll deal with it. All right, so that's one of the 6. How'd you do? I am not going to repeat any of those. So that one's done. We got 5 more to try. And I lost my ruler, and it's so hot. Oh, my eraser, and it's getting hot. Woo! All right, well, I forgot how to do this one. I forgot how to do, if you have A equals 4, B equals 5, and C equals 6. Did I say anything about a right triangle? No. Do I need to? No, because 4 squared plus 5 squared isn't equal to 6 squared. All right. What do I use? I can't use right triangle trig. I can't use law of sines because I don't have, like big B is equal to 47. I don't have anything like that. I guess I got to use law of cosines. Oh, the question is, am I going to end up with this or this? Jeez. Oh, you know what? I think I can get a ratio out of this thing. Yeah. Now the question, what do I want to put? Well, I put B up here. I guess I better find B. Oh, yeah. We went through that solving. So I want B. I know B squared is equal to A squared plus C squared minus 2AC cosine B. You may not have known that because I hadn't put it up there yet, but now I have. Does it look like there's a pattern here? Yes. Is there a pattern for person, woman, man, camera, TV? I think there is. Boy, it's a shame that the man needed a pattern to remember 5 words. A little bit of politics here, I apologize. But talking to my friends in India. Me, couldn't remember 5 random words? You have a person. Oh, yeah. Person's either a man or a woman, so that's helpful. Oh, yeah, I'm a TV star, and TVs have cameras. Oh, it's kind of like our word of the day. Anyway, back to this. So we want to do this in one memorized moment. Remember, that goes over, that goes over. This gets divided. Inverse cosine. So the inverse cosine of minus plus. Guess what? There's a little mnemonic here that's helpful. We're trying to find big B. So big B angle equals, well, put it at the end. Everything else is the other numbers. And Google's been kind to us. They've given us an arc cosine calculator. Okay, we're going to practice that. I don't expect you to own it in the last 2 minutes. Right? We're going to talk about it now the rest of the term. Okay, so that's how you solve a side situation. Finding an angle given 3 sides. Okay, 2 out of the 6 have been done. Ooh, I'm going to give you a 90-degree triangle. Now I'm going to tell you A is 4, A is 5, B is 6. Can you find big A? Okay, remember you're pausing, I'm not. It's getting too hot. I'm trying to find big A. It's 90 degrees. I'm going to draw it in the first quadrant. Good drawings get good answers. B is a little longer. So this is 6. That's a little longer than the 5. Okay, so I know I'm a little less than 45 degrees. If this was 6, it would be 45. How do I find it? I got a ratio. So what kind of language do I use? Inverse. I see the tangent ratio. So tan inverse of 5/6. And I have not gone to Google for an arctan calculator. I hope they have one. I'll find out after this video. If they don't, then I don't know. Maybe you find the other third side and then do arc sine or something. I assume there's an arctan calculator. All right, and I'm assuming that's 43 degrees, something like that. What is it in radian measurements? Okay, so this is 1 radius. Ooh, that's big. 1, okay. It's less than 45. 45 is pi over 4. Pi over 4 is 3.14 divided by 4. So that's 7.34, 7.8. So 0.78, sorry. I think I just screwed up. Sure. I'm doing tangent here though. So I'm not that familiar with tangent ratios of arctan. Okay, so I'm going to stop. I'll think about that on my own time. Okay, so we now have done 3 situations. How about I give you A equals 4, angle B equals, let's say 50 degrees, and little c is equal to 6. Okay, what am I trying to find here? I guess I'm trying to find a little b. I didn't say anything about 90 degrees. I didn't say anything about 90 degrees. So right triangle trig's out. Can you do law of sines? No, I don't have an A to A, a B to B. I don't have that knowledge. I would need to know both of these values to do law of sines. I can't do right triangle trig. I can't do law of sines. There's only one left, law of cosines. All right, so what do we have? You've only seen it a couple of times. Law of cosines. We're trying to find B. B is a length. Guess what? That's a square root. And guess what a square root is? It's a length. So I want you to memorize the one line of work. And the one line of work is here. What goes here? A squared plus C squared minus 2AC cosine big B. So all we're going to do is fill it in. Use a calculator, you got your answer. 16, 4 squared, 16. Let's just do 4 squared, 6 squared, 2 times 4 times 6, times the cosine of B, and we have B, it's 50 degrees. What is the cosine of 50 degrees? Some kind of ratio between 1 and -1. Right? It's in the first quadrant, so it's positive. So this is just one number. That's a number. Okay, and it's minus 48 times the cosine of 50. Well, the cosine of 45 is 0.71, so the cosine of 50 has got to be less. So how about 0.67 as a rough guess? Okay, that's going to give me a number. I'm going to take it away from these, and I'm going to take the square root, and I am going to know. Let's see if I can get a drawing of this 50 degrees. 45, that's 50. Okay, we'll call this 4, 50 degrees. We'll call this 6. Okay, and what was I trying to find? Little b. I was trying to find that. Okay, and the square root of that is going to tell me that number. I think we've done 4 of the problems. It's getting hot, getting hot. Oh, geez. All right, so let's say we have A equals 5 and C equals, and we're going to use, we're going to find, and big A, what am I trying to find it? Big A, okay, I'm going to say C. C is 5. I'm going to say C is 10. So little c is 10, and big A is 31 degrees. Can you find little a? Remember, you're pausing the video. This is what leads us to nice vector work down the road. We'll have to get to physics class. All right, so we got a good drawing, 31 degrees. We got 10. All right, what you're going to find is your answer is 10 times the sine of 31 degrees. We want to get good with that before the end of the term, but that'll be this fall. How did I get that? Okay, and we're going to call this y right now. We're going to call it y. Y equals little a, but I'm going to use y. So what do we see? I see that the sine of 31 degrees is equal to y divided by 10. That's the sine ratio. So all you do is move the 10 over here. 10 times the sine of 31 degrees is that y value. Anybody want to guess what this x value is? Turns out it's 10 times the cosine of 31 degrees. Okay, it's going to be very useful. We're going to work towards that so we can answer that like this a month from now. Okay, maybe not because I don't know what the schedule is going to be in August, but a month from September, September 1st, the end of September, we're going to be able to do those in our sleep. Okay, that is if your net is working. Okay, there's one left. What was it? I think it's the law of sines. So let's say that we have a little b, and I know that big B is equal to 47 degrees, and I got little a equals 8, and big A is equal to, I don't know, 43 degrees. Okay, so how do I find B? 90 degrees? No, I can't use right triangle trig. Do I have an angle in its opposite side? Yes, so law of sines. Put your unknown in the numerator. B compares to the sine of 47 degrees equals 8 compared to the sine of 43 degrees. Okay, law of sine says that has to be true. So all you're doing is moving the sine of 47 degrees here, right? And that's a ratio, a length, right? It's also, yeah, it's a ratio, but it's a length. And what's that length going to be? Your answer should be a little bit bigger than 8, right? 43 goes to 8, 47 is a little bigger, so this has to be a little bit bigger than 8. Yeah, go throw it in your calculator and find it. Probably 8.5, 8.8. Go find it. All right, I'm signing off, guys, because I am extremely hot here. I think I'm going to jump into a cold shower and sweating. All right. So hopefully that recorded well. Hopefully you guys are staying safe. I know things are not good over there right now, but you hunkered down and really taken a lot of precautions. I hope we do as well as you do. All right. I don't think we're going to have everybody, take off their clothes at the entrance like you do at yours and then throw the clothes in a closet for a week. Okay. But you got a little smaller operation over there. All right. So be good. And I hope I'll send you an email. I know that the power's out up at NMH, so there's no air conditioning, no nothing. I got a feeling out to Mom and Leela and Gabe and the dog are frying. Hopefully they're getting somewhere out on a porch or somewhere in the shade. And hopefully they're fixing that soon. Okay. I'm going to stop the recording, say goodbye, upload this to the YouTube channel sometime today. Be good.